Hello everyone, my name is Mr. Asnake Hailu and I'm a physics lecturer at Awasa University. In this session, we'll be talking past entrance exam problem together. I hope this will be boost your confidence for the real exam. እኔ መምህር አስናቀ ኃይሉ እባላለሁ። በአዋሳ ዩኒቨርሲቲ በፊዚክስ የትምህርት ክፍል መምህር ነኝ። የባለፉ ዓመታት የዩኒቨርሲቲ መግቢያ ፈተናዎች የፊዚክስ ፈተና ጥያቄዎችን አብረን እንሰራለን። ይህ ለዋነኛው ፈተና ያዘጋጃል የሚል ጽኑ እምነት አለኝ። መልካም ቆይታ። ጥሩ። So number 1 says, which one of the following set contains only vector quantities? So before going to the alternatives or to alternatives, first we have to remind what we had learned in our previous class about vector physical quantities. As you know, vector is or vector are quantities that are specified by both magnitude and then direction in space. Example of vector physical quantities: displacement, acceleration, force, momentum, velocity, and etc. Another physical quantity is known as or are known as scalar physical quantities. As you know, scalar physical quantities are quantities which are completely specified by a number and a unit. Example: mass, time, volume, speed, and etc. Great. Now we will see the alternatives. Choice A says or contains energy, acceleration, and then time. Among them, the only vector physical quantity which is illustrated here is acceleration. The rest, energy and time, they are known as scalar physical quantities, and hence choice A automatically cancel because this is not the exact answer. B. Under B, force, temperature, and time are narrated. Among them, the only vector physical quantity is known as force, whereas temperature and time, they are not vector physical quantities, rather than they are scalar physical quantities, and hence B cannot be the answer. C. Velocity, displacement, and then momentum. Velocity is a vector physical quantity. Displacement also a vector physical quantity. Momentum also a vector physical quantity. And hence, our answer will be or could be C. But to decide, first we have to see alternate D. Alternate D says mass. Under alternate D, mass, length, and volume, these are illustrated. Great. Among them, the only vector physical quantity is known as length. The rest, mass and volume, These are not vector physical quantities, rather than they are scalar physical quantities. Great. And as what I said, vector quantities have whose magnitude or size and in direction, and in reverse, scalar quantities have only magnitude. From this conclusion, our answer will be C. So therefore, the set containing only vector quantity is C, velocity, displacement, and then momentum. Great. Number two. Number two says, which of the following does belongs to the fundamental physical quantity? So before selecting from the given alternatives, first we have to remind what we have learned in our previous class. Great. Fundamental physical quantity, as you know, or quantities that cannot be derived from other quantities. If two or more fundamental physical quantity join together, yields gives another physical quantity known as right physical quantity. Great. On the behalf of what we said, we'll select the one who belongs to the fundamental physical quantity. The first alternative is velocity. Velocity is vector, yes. At the same time, it is derived because velocity is the combination of two fundamental physical quantities, displacement and then time. And hence velocity does not belong to the fundamental physical quantity. B, volume. Volume is a derived physical quantity, and then it is a scalar physical quantity. Volume is the combination of three fundamental physical quantities. Length times length yields to us a volume, and hence volume does not belong to the fundamental physical quantity. Length is one of the fundamental physical quantity, and then length does belongs to the fundamental physical quantity. But to decide, we have to see choice D. It is force. Force is a vector physical quantity, and then derived physical quantity. Force is a vector as well as derived physical quantity. It is as a result of four fundamental physical quantities, and hence force does not belong to the fundamental physical quantity. Our best answer could be C. And now we'll see something about length. So length is a fundamental quantity used to measure a distance. Other fundamental quantities include mass, time, and then temperature, and hence choice or options A, B, and D. A, B, and D are derived quantities, meaning they are defined based on the fundamental physical quantities. And hence our lovely answer is length. Correct. Number 3 says 15 cubic centimeter of a wood is floating on water, and then 15 cubic centimeter of iron is totally submerged. And then we requested which has a greater buoyancy force or upthrust force on it. Great. The wood is floating on the water. Despite the fact that the volume of the wood and then the iron is the same, but the wood is floating. What the meaning of floating? Floating means part of the volume is submerged, part of the volume is not submerged or out of the water. Correct. As you see, the iron is totally submerged. That means this much of the water displaced. Correct. But in the case of the wood, not this much of the volume of the water displaced. It's much small volume may be displaced because of the wood. Correct. Anyhow, we know something. What that? The upthrust force or force of buoyancy is equivalent with the weight of the displaced water in this case. And then that is the density of the displaced water, or simply the density of the water times the volume of the displaced water times acceleration due to gravity. Great. Despite the fact that the volumes are the same, but the displaced water due to the wood and then the displaced water volume due to the iron is quite different, and hence the upthrust force in the case of iron and then in the wood is quite different. Generally, since iron is denser than the wood, it displaces more water when submerged. When submerged. Even though they have the same volume. Therefore, the iron experiences a greater upthrust force or buoyancy force than the wood. Great. Look, choice 1 it says A. It says the wood. Of course not. As what we have discussed. Both have the same buoyancy force. Completely wrong. And then D says cannot be determined without knowing their density. We can. And then it can. Determined. Because every information is given to us. Great. ስለተነገረን ዴንሲቲውን መናገር እንችላለን. Guys. Okay. And then C says the iron, definitely. The iron. Great. So the answer is C. Again, look, there's እዚህ ጋር ማወቅ ያለብን ነገር የውሃው ቮሊዩም በእንጨቱ የተገለለና በአይረኑ የተገለለው ወይም ቦታውን እንዲለቅ የተደረገው ተመሳሳይ አይደለም። የአይረኑ ቮሊዩም 50 ኪዩቢክ ሴንቲሜትር ወደ ውስጥ ጠለቀ ማለት ይህን ያህል የውሃ መጠን ቦታውን ይለቃል ማለት ነው። የእንጨቱን ደግሞ ስናይ የጠለቀውን ያህል ቮሊዩም ውሃ ይለቃል ነው። እንግዲህ ቅድም ለማለት እንደሞከርነው ይሄ ወደ ላይ የሚቀስር ኃይል ቦታውን ከለቀቀው ከውሃው ክብደት ጋር እኩል ይሆናል ነው። እንደዛ ከሆነ የአይረኑ ወደ ላይ በአይረኑ የሚቀስርበት ኃይል ከውሃው ኃይል ይበልጣል። አንድም እንጨቱ ያልጠለቀበት ምክንያት ዴንሲቲ የውሃው የእንጨቱ ዴንሲቲ ከአይረኑ ዴንሲቲ ስለሚያንስ፣ በሌላ መልኩ የውሃው ዴንሲቲ ከእንጨቱ ዴንሲቲ ስለሚበልጥ ወይም የእንጨቱ ከውሃው ስለሚያንስ ነው የተንሳፈፈው። አይታችሁ እንደሆን አይረኑ ጠልቋል ማለት የአይረኑ ዴንሲቲ አይደለም ከእንጨት ከውሃውም ዴንሲቲ ስለበለጠ ጠልቋል። ዞሮ ግን የወደ ላይ ቅስራው ኃይል የአይረኑ ከእንጨቱ ይልቃል። ግሬት። እስቲ ትንሽዬ ማብራሪያ እኔ according to Archimedes principle stated that the buoyant force on the object submerged in fluid is equal to the weight of the fluid displaced by the object. Great. This principle explains why the objects with lower density float, and then why the object experiences an upward force on the submerged. Since the iron is denser than the wood, even the iron density is denser than the water in a house. It displaces more water when submerged than the wood, even though despite the fact that they have the same volume. Therefore, the iron experiences a greater buoyancy force. Great. Number 4. An object moving in the x or in the positive x direction experiences an acceleration of positive 2 meters per square of second. This means the object, it says, great. እንደ ቀድሞኑ ወደ ምርጫዎቹ ከምንደረደር ቀድመን ከምንሮጥ ቆም ብለን እነዚህን ሁለት ነገሮች ማጤን ይጠበቅብናል። አይታችኋል። ይሄ ፖዚቲቭ ኤክስ አክሲስ ነው ቁሱ እየተጓዘ ያለው። ኦኬ ይሄኛው ደግሞ የሚያሳየን ቁሱ በእያንዳንዱ ሰከንድ ፍጥነቱን በ2 ሜትር ፐር ሰከንድ እየጨመረ መሄዱን ነው የሚነግረን። ይሄ በጣም ጥሩ ልብ አድርጉ። ይሄ ፖዚቲቭ ሳይን የሚነግረን እየጨመረ መሆኑን ይነግረናል። ታዲያ ይሄን ደግሞ ስንተነትን ይሄ ማለት 2 ሜትር ፐር ሰከንድ ማለት ነው። ያ ማለት በእያንዳንዱ ሰከንድ ፍጥነቱን በ2 ሜትር ፐር ሰከንድ እየጨመረ ወደዚህ አቅጣጫ ይጓዛል ነው። ጥሩ እስቲ ምርጫዎቹን እንይ። So look, we have to know in depth and then in detail about the positive x and then about the positive 2 meters per square second. This is definitely displacement toward this positive x-axis. This is definitely acceleration. We will see an increment of velocity in each second by this much amount, that is 2 meters per second. Great. Now we will see the alternatives. Okay, A says travels 2 meters in every second. No, it does not mean that. As what we have discussed earlier. It does not mean that. Great. B, it decreases its velocity by 2 meters per second every second. No. It does not mean that. Rather, as what we said, there is an increment of 2 meters per second every second. But this is completely wrong. ግን ይህን አማራጭ ማስተካከል ይቻላል። ምኑን ብቻ በመቀየር እቺ ዲክሪዚንግ የምትለው ኢንክሪዚንግ ብትሆን ይህ መልስ ነው የሚሆንልን። ትክክለኛ ማገላለጽ ነው። ቀድመን እንደጠቀስነው ማለት ነው። ሲ is decreasing its velocity by 2 meters per second every second. Definitely. አዎ ይሄ ትክክል ነው። ይሄ አማራጭ ትክክል ነው። ግን አማራጭ ትክክል ቢሆንም የቀጣዩን አማራጭ ማየት አለብን ለመወሰን። D is traveling at -2 meters per second. Oh, this is completely wrong. This is completely wrong. Our answer is definitely C. Look. Great. A positive acceleration of 2 meters per square second indicates the object's velocity is increasing by 2 meters per second every second. Correct. Option A is incorrect because it only tells us the direction, not the change in velocity. Option B and D describes, require with a negative acceleration. Great. Number 5. Which of the following situation is impossible? Impossible. Which one of the following situation is impossible? Great. Can we see alternate A? Great. What he says? An object has velocity directed east and acceleration directed west. Yeah, it could be. It could be in the case of deceleration. Alternate B. An object has velocity directed east and then acceleration directed east. Yes, it could be. It could be. Alternate C says an object has constant non-zero acceleration and changing velocity. Yes. As you know, acceleration is the rate change of velocity. Despite the fact that acceleration is constant. ይህ ግን እንዳትሳሳቱ፣ ይህ አይቀያየርም አይለዋወጥም ማለት 2 ሜትር ፐር ስኩዌር ኦፍ ሰከንድ ቢሆን ለምሳሌ ወይም ለምሳሌ 3 ሜትር ፐር choice says an object has constant non-zero acceleration and changing velocity. This is completely correct. Despite the fact that acceleration is constant, but we may say the variation of the velocity. For instance, take acceleration as example, 2 meters per square second. What this means? Acceleration is constant 3 meters per second. Acceleration is constant 3 meters per square second. This means there is a variation or there is an increment of velocity with 3 meters per second. And then C is correct. Choice D says an object has constant non-zero velocity and changing acceleration. How it could be? If the final velocity and the initial velocity equal, changing velocity becomes 0. 0 over change of t is 0. That means acceleration is 0. And hence, we never expect changing of acceleration. And hence, D is completely wrong perception. Great. According to the law of motion, an object with constant non-zero velocity experiences 0 net force. If there is no net force, the object's acceleration must also be 0. So an object cannot have both constant non-zero velocity and changing acceleration. Great. Number 6. It deals about uniform circular motion. In uniform circular motion, great. Please go and remind what you are learning in your previous class about circular motion. As you know, circular motion could be vertical circular motion or horizontal circular motion. But in this case, or a uniform circular motion means, in another word, horizontal circular motion. In the case of horizontal circular motion, the magnitude of the velocity is constant, that is, the speed is constant, but the direction of the velocity varies in each point within the path. Great. Because of this variation of velocity, something may arise that is known as centripetal acceleration. And then this centripetal acceleration could be calculated as scale of tangential velocity over r. Great. Can we see the alternatives to decide? A. Both velocity and acceleration are constant. No, velocity is not constant. Rather than the magnitude of velocity, yes, constant. That is, speed is constant with this motion. Speed is constant, but the direction of the velocity is not constant. The magnitude of the velocity constant. Great. Velocity changes, yes, and acceleration is constant, of course. Our acceleration is centripetal acceleration. So centripetal acceleration is always constant and interacts to the center of the circle. Whereas velocity changes because of changing direction in each point within the path. See, velocity is constant and acceleration changes. No, velocity is not constant. As well, acceleration not changes. And hence this is automatically cancelled. It's just not right in ours. D says both velocity and acceleration changes. No, this is not right. And our answer is B. Yes. In a uniform circular motion, the object's speed, known as the magnitude or size, remains constant, the same, but the direction of the velocity keeps changing due to the circular path. This change in direction yields a centripetal acceleration towards the center of the circle. Great. Dear my students, don't forget, just share my channel, like it, and then put your own comment. Till the next session, I'm interested to say goodbye. Bye bye.